Imagine being able to teleport anywhere with just the snap of a finger.
So you could easily go to the park, your school, or even the grocery store. Well, what if I told you that almost 50% of your DNA can teleport? I mean, it's not actual teleportation, but this can be seen in the human genome with transposons, which are also known as transposable elements or jumping genes. The mobilization of these DNA segments is known as transposition. Let's take a closer look. Some transposons use a cut and paste technique similar to that of a computer, but in reality, transposons use transposase enzymes to help cut themselves out of a segment of DNA and paste themselves into the target site of another. Transposition changes the human genome, which may cause cancer, neurological diseases, hemoglobinopathies, and other common human diseases. Specifically, the transposition of transposons such as line 1 and ALU have been implicated as the cause of many types of cancers in humans.
So, how can we stop transposition in our DNA?
Well, let's go back to the teleporting situation and pretend that you had to bring a large rock with you. Teleporting and just regular moving would be harder. While we can't physically place a rock on our DNA or tell transposons to stop moving, the human body uses a similar process to stop the mobilization of transposons. The addition of methyl groups to DNA is suggested as an epigenetic silencing mechanism of transposition. Methyl groups are comprised of one carbon atom bonded to 3 hydrogen atoms. During DNA methylation, methyl groups are added to sites of DNA where cytosine and guanine are bonded with phosphate bonds. Sites of DNA where cytosine and guanine are bonded are known as CpG sites. This phenomenon is commonly studied using maize, or corn, because 85% of its DNA is made up of transposons, compared to the 45% of human DNA that is made up of transposons. Even though us humans can't teleport yet, transposons have been performing a very similar process, and have been doing so for a long time.